use the Excel table that I made for interpolation. So you have a temperature of 4.1 and you know that it's a saturated liquid. Those are the two properties you're given. You want to find the other intermediate values and you don't want to use your calculator for every single one. So what you're going to do is you're going to come to this direct interpolation here. I'm going to show you how to do double interpolation. That's when you have to do it for a superheated vapor or subcooled liquid, and I'll make a separate video on that. But this one is just for between two rows. So you say your temperature is 4.1. So up here, up here, 4.1 is your known intermediate value of temperature. And then up here, you're just going to put the value of whatever your known value is, and you're going to put whatever number is right above that. So above it, 4.1 would be 4 right there. So you put in 4. Below 4.1 would be 5. So that's below. Boom. So now you're all set up pretty much. So all you have to do to find the intermediate value of any of these is just plug in the above and below values. So say I wanted to find pressure. I would put in for the above value 0.00813. And I'd put in the below value 0.00872. And boom, it gives me the intermediate value of 0.008189. And you can do this for pretty much any of the other values that you need. And honestly, it doesn't really matter which box you use because they all use the same formula. So I just put these here in case you wanted to put them all at once and see them all at once on the table. So that's how it works, and that's, yeah, pretty simple. You just put in your known values, upper and lower bounds of your known values, and then the upper and lower bounds of your value you're trying to find. Now, for double interpolation, I guess I'll just fit it in here because why not? Delete. Okay, so double interpolation, a little bit more complicated. So you come to a situation where, not on the assignment, but on the lab, you will have to do double interpolation. Say you're here in a superheated water vapor, and say you're given a pressure of 0.5 bar. So obviously you can see it doesn't show up in here, this table or in this table. So you're given a pressure of 0.5 bar and you know that it is, and you have to know something else. Like you'd have to know that it would be, the temperature would be, let's say 130. Yeah, we'll go with 130. So 0.5 bar is your pressure and 130 is your temperature. Now obviously you can't directly interpolate between two rows because there's not a table for pressure at 0.5 bar. So what you have to do instead is do a double interpolation, which is basically doing this, interpolating between 110, 120, and 160 here. You'll get a new row, interpolating again here, and then interpolating between those two rows. So first of all, let's just do the top row, take it one step at a time. So say you're trying to find specific volume in this case. So you're trying to find specific volume. So first, before anything else, come here. This looks confusing, but it's not really confusing. So here is going to be the top. So whatever like table appears on the top, like for example, in this case, it'd be 0.35 bar, and the bottom table would be 0.7 bar. Or if you're trying to interpolate for 1.2 bar, top will be 1, bottom would be 1.5. Pretty straightforward. So you're going to come here. Your pressure for this table is 0.35 bar, but you're actually not interpolating, you know, for pressure yet, because you have to find specific volume at this pressure and temperature, and then specific volume at this pressure and temperature, and then you can interpolate between those, if you know what I mean. So first we have to interpolate for temperature first. So temperature is 130, above is 120, below is 160. This is also the case for the below table. So I'm going to put this same values in here. And I'm also going to put in, so here, you're going to put in whatever the pressure is. So the pressure is 0.5 that we're trying to look for. And then the above table is 0.35. Below table is, what is it, 1.0? 7.7. So 0.7, put them in there. Now we're trying to find specific volume. Again, it doesn't matter which one of these rows you use. I put them here just for convenience if you wanted to see every single property at once. But yeah, so we're trying to find specific volume of, I guess, the vapor in this case. Or no, just specific volume, because it's a superheated vapor. What am I saying? Anyway, specific volume at 130 temperature at this pressure. So our above value is 5.163, sorry. Below value is 5.696. So now it gives us this, and this is the specific volume at 130 degrees Celsius for 0.35 bar. Okay, so now we found that we found the right temperature, but our pressure is still off. So we have to come here, find a specific volume. Yep, right here. You got to be careful. Sometimes it's to the 10 to the third, so you got to be careful. Have to divide by 1,000. In this case, you don't. So you come here. The top value is 2.571. 2.571. Bottom value is 2.841. 2.841. And so you can see, as soon as you fill in those four values, it interpolates between these two. So you've already interpolated between these, and then it automatically puts these in this table. So it inputs this one for this value, this one for this value. Sorry, yeah, this one for this value. And then it interpolates again between the pressures this time, right? And so that's going to be your specific volume at a pressure of 0.5 bar and a temperature of 130. And that works for all the any of the properties. And you'll never have to. There won't be any tables separated by temperature, I guess, unless you were saturated. But if it was saturated, you would have a direct lookup usually. So yeah, so that's how to use it. Double interpolation, direct interpolation, and again, yeah, if you want to have more values of double interpolation, you just plug in all your values here, plug in them all here, and it'll automatically give you the intermediate value right there. Hopefully that helped.